So I got a second question to go over this slide here. What I'm going to do though is actually approach it from a slightly different manner, and then we'll come back. So hopefully this helps make it a little bit more sense. I'm going to look at this in the context of looking at it as essentially metabolic supply and demand. So what I mean by metabolic supply and demand is essentially the demand that we put on our muscles in order to be able to generate contractions. We require a certain level of ATP for that to happen, right? The metabolic supply then is the metabolism we use in order to generate that, right? We have three different types of metabolism that we can use, right? We have a PCR system, we have anaerobic glycolysis, and we have aerobic metabolism. Right? We can just lump these two in as both anaerobic, which means that they are independent of oxygen, and aerobic, which means that it requires oxygen. Right? So these are our ways that we're going to be able to meet metabolic supply and demand. So what I have here is essentially we'll look at three colors, but for example, if you're at rest, right, the amount of ATP that you require that we'll draw here in red is relatively constant, right? As soon as you step on a treadmill, let's say you step on a treadmill at about 3 miles an hour, which is a nice slow walk, your metabolic demand goes up instantly, right? You need that ATP that we need to be required to reach that. So we'll just say this is 3 miles an hour. Right, so you reach that almost instantly, and as you guys have experienced and should know that we have no problems walking at 3 miles an hour. So our metabolic demand is enough ATP to produce contractions for a speed of 3 miles per hour, and our ATP generated, if we then switch over to our blue color here, our ATP generated will look exactly the same. Right? So our ATP supply and demand are always equal. The only thing that's not equal then is how we get to that supply and demand. So one thing that we'll note is that oxidative metabolism takes a little bit of time in order to get going. Right? So at rest we have we're using oxidative metabolism, we're generating ATP, again, in those oxygen-dependent pathways through the Krebs cycle and electron transport chain. Very efficient, makes a lot of ATP, much more than anaerobic, and is therefore our preferred source. Right? So it takes a little bit for it to get going, and that's kind of the figure that we started at here, is that we start to see this exponential increasing curve here. Right? So we can think of this green line as the rate of ATP production. And you can see that at all points in this line here, we are not producing enough energy from our aerobic systems in order to match the ATP demand. So therefore, what we can think of this is this gap here is all done by requiring anaerobic systems in order to do that. Right, so that's how we meet our metabolic supply and demand, is by supplementing our aerobic metabolism with anaerobic. Again, this is a nice easy walk. So within a couple minutes, remember 2 to 3 minutes, we reach steady state. Steady state means that we can assume that almost all of our ATP production is now coming from aerobic metabolism. So therefore we can say our supply and demand is met primarily by aerobic. If we were then to increase the speed of the treadmill, let's say we increased it to 5 miles an hour, right? Our ATP demand would go up instantly. Our ATP supply would also go up instantly and would match exactly that. However, same as before, our aerobic systems would somewhat lag. So we would see a rapid rise, but we would ultimately reach this plateau or flat stage known as steady state metabolism. And again, all this ATP here is met by the anaerobic system. So if we switch back really quickly So then if we switch back to this slide here, essentially that's what we're doing. So these numbers, 50, 100, 150, these are essentially just watts or power outputs, right? So this is, you know, the equivalent, not quite exactly the same, but, you know, 2 miles an hour, 4, 6, 8, 10 miles an hour or something. So as you can just think about this as increasing speed or workload. Again, here we're only talking about oxygen metabolism. And in this situation, what we're doing is we're measuring VO2 or oxygen uptake as a surrogate marker of the aerobic capacity to produce ATP. Right, so we see that exact same thing. We see aerobic oxygen consumption going up, so aerobic ATP goes up relatively quickly here and then plateaus out. If we were to increase or work at a higher load, again, our ATP production has to be higher. We see this sharp increase, and then we reach steady state. Again, usually between 2 and 3 minutes, we reach this plateau or flat stage, which equals steady state metabolism. And the importance of steady state metabolism is, again, that we can ultimately then assume that all ATP production is via aerobic metabolism. So I hope that helps.